This video is on integration by substitution. So this is a method that we can use for doing integration, but it doesn't work for everything. You just got to be able to see and recognize that integration by substitution is to be used. Now, this is kind of the general formula for substitution, where we have the integral of a composite function, the f of g of x, so that first part is like the f of g, times by the derivative of g dx. So what we're looking for is the derivative of one part of the function can be seen somewhere else, and then we'll do a substitution. So as we do the examples, you'll see how this works. So for part A, we want to find the integral of 3x squared plus 7x all to the power of 5 multiplied by 6x plus 7 dx. So the first thing we want to do here is look and see is the derivative of either 3x squared plus 7x or 6x plus 7 seen in either part. Now what we'll notice is u equals 3x squared plus 7x. The derivative of this part is 6x plus 7, which can be seen here. So we want to be able to do the derivative of one part, and we can see the derivative somewhere else in the original function. Now what we do here is we're saying that du over dx equals 6x plus 7. So I'm going to substitute, instead of 6x plus 7, I'm going to substitute du over dx. So we'll still have our integral, and so the first bit now, we're actually going to put u in as well. So we're going to substitute u instead of 3x squared plus 7x. So we'll have u to the power of 5 multiplied by the 6x plus 7. We're going to substitute with du dx, which is what we just found before, dx. Now what happens here is you'll see that we have a dx on the top and a dx on the bottom. So these two end up cancelling. And we are left with the integral of u to the power of 5 du, which we can then do. So the integral of u to the power of 5 is 1 on 6, u to the power of 6 plus c, and then we can just sub in u again. So we'll have 1 on 6, 3x squared plus 7x. So replace u with what we defined u as at the start, to the power of 6 plus c. And that's integration by substitution. So let's have a look at part B, because part B includes something else we have to be aware of. So now here we've got the integral of 2x times e to the power of 3x squared dx. So our u is going to be 3x squared, and do the derivative, so du on dx will equal 6x. Now, if we look at this, 6x isn't in our original function, but 2x is, and 6x is 3 times 2x, and that's okay, we can work with that. So when we rewrite this, our integral will be 2x. Now remember, the derivative part is what we replace. Now 2x, what we actually have to replace that with is a third of du dx. Because if you think here, du dx, if you divide both of these by 3 on this side, we'd have a third du dx would equal 2x. And so we can replace that into our equation, and we'll have the e. Now 3x squared is our u, so we can put e to the u dx. Once again, our dx's will cancel, and so we'll end up with the integral of a third. I'm going to write this nicer, e to the u du, and now we can do the integral of this, which we all know is just the same because it's an exponential. So a third e to the u plus c, and then just put u back in. So we'll have a third e to the power of 3x squared plus c. So that example, remember, when we do the derivative, we may not see it exactly, but there may be a multiple. So then we just have to rewrite the second part of our derivative. So you see in the red here where I'm just starring, we could rewrite du of dx is a third of du dx equals a third of 6x, which is 2x. Now part C. So here we have the integral of the square root of x cubed plus 2x multiplied by 3x squared plus 2. So identify which our u will be, and if you do that, you'll see it's the x cubed plus 2x, because the derivative of this, so du on dx, equals 3x squared plus 2, which we already have in our function. So then we can just do our substitution. So we'll have the integral of the square root of u, because x cubed plus 2x we labelled as u, multiplied by 3x squared plus 2, which is now du over dx, multiplied by dx. Our dx's cancel, and we are left with the integral of the square root of u du. And then we just do our integral. So the square root of u is the same as u to the power of a half. If we do the integral of this, we'll have 1 on 3 on 2. So remember, add 1 to the half, u to the power of 3 on 2 plus c, and then tidy this up. So we'll have 2 on 3. Put u back in, which is x cubed plus 2x, all to the power of 3 on 2 plus c. Now just be careful in the solutions to these from your textbook questions in the booklets. They may write the answers to some of these slightly different when we have powers of 3 on 2, and that's fine. But in an exam, you would be able to leave it like that. Now for part D, we've got the integral of 8x cubed minus 15x squared divided by 2x to the power of 4 minus 5x cubed dx. So first of all, we're going to look for our u and our v. So our u will be the denominator, which is 2x to the power of 4 minus 5x cubed. Let's do our derivative. So du dx of this would be 8x cubed minus 15x squared, which we already have in our numerator. So now we can just do our substitution. So 8x cubed minus 15x squared is our numerator, so that will be du on dx all over the denominator 2x to the power of 4 minus 5x cubed, which is u. The x's will cancel, and we are left with the integral of 1 on u du. Now the integral on 1 on u is ln, so remember it's ln, the absolute value of u plus c, and then we can just put u back in. So it'll be ln the absolute value of 2x to the power of 4 minus 5x cubed plus c. And that is integration by substitution.